Hello, you're most welcome once again to my channel. This is still your tutor Peter Ikaja, and today I'm going to be taking you through still the continuation of integration, but particularly using what we call the sign substitution. Now, sign substitution is a technique that we use to integrate functions of the form 1 out of square root of a squared minus b squared x squared. I quoted it here very well in the brackets that we shall be focusing on integrals of that form. And we are saying to integrate a function of this form, we shall do some special substitution. And what is that special substitution? To let the whole of a squared minus b squared x squared equal to a squared minus a squared sine squared u. Something unique is that the a squared we have here is the a squared we have maintained here. That is very unique. And then you compare. By comparison, a squared definitely cancels with a squared. The negative cancels with the negative. You remain with b squared x squared is equals to a squared sine squared of u. Then when you take a square root on both sides, you will get bx equals to a sine of u. And when you make x the subject, x becomes a out of b sine of u. And from this level, if we reach a point of integrating, at some point, we shall be required to know the expression of u in terms of the other variables. And in this case, we can easily see that if bx is equals to a sine of u, at a later stage, we shall realize that u is actually going to be the sine inverse of bx divided by a. That is at a later stage. But we shall basically look at functions with known constants so that we make life easy. But this is a general form that I've just given to you. Let's right away go to the examples. Let's go to the examples, and we shall start with the very simplest example. Examples number one. Someone can tell you to find integral of 1 out of square root of 1 minus x squared with respect to x. If someone asks you to find this integral, you need to simply begin by doing the following. In my solution, I will say, if this is the integral 1 out of square root of 1 minus x squared with respect to x, then I will definitely say let 1 minus x squared. I have taken a choice. Some other person could take another choice. I would take 1 minus x squared to be the same as 1 minus sine squared of u. Remember, there is a constant which is 1 corresponding to our a squared in the previous comparison. Now, this one is actually maintained here, and it's also here, though it is silent. It is also there, though it is silent. So when you do this, then do the comparison. Definitely x squared becomes the same as sine squared of x, and therefore, sine squared of u, I beg your pardon, and therefore x now becomes sine of u, when you take a square root on both sides. Now, from this level, we need to know something. We need to know something that we are going to differentiate. We're going to differentiate with respect to u. That means we shall say the x du is definitely going to be cos of u. And that means the x at the end of the day becomes cos of u du. Now at that point, we can go back and do the substitution. Come back here and say now, integral of 1 out of square root of 1 minus x squared with respect to x is going to be the same as integral of 1 out of square root of, instead of writing 1 minus x squared, remember, you already called the whole of it to be 1 minus sine squared u. So I will say 1 minus sine squared u. But instead of writing dx, because the variables are now changing, we shall write cos of u u. And then from that level, we need to remember that 1 minus sine squared of u is the same as cos squared of u. So we shall have integral of 1 out of square root of cos squared of u multiplied by cos of u with respect to u. Then from that level, what we do to realize that cos squared of u and a square root is the same as cos of u, which will cancel out with cos of u. And at the end of the day, we shall have integral of 1 with respect to u. And definitely, when you integrate this, you're supposed to get u. If you get u, you need to remember that to be very, very, very clear, our integral is in terms of x. It is in terms of x, as you can see from the right, from the very start. That was our integral. So instead of writing u, I need to bring back the substitution. So this would be u, but I will go back here and say, but what is u in terms of x? Definitely from this step, we can all agree that u is the sine inverse of x. U is the sine inverse of x, and therefore I'll write here sine inverse of x plus our constant of integration c, and that is normally an arbitrary constant of integration. That is what we need to know. So whenever we integrate 1 out of square root of 1 minus x squared with respect to x, we get sine inverse of x plus a constant. Let's move to example number 2. Okay, example number 2 says we find integral of 1 out of square root of 2 minus 3x squared with respect to x. What shall we do? Again, I will take the simplest method. So I will say we let 2 minus 3x squared to be the same as 2 minus 2 but sine squared of u. Then if you do the comparisons, obviously, most of the terms cancel out. So we remain with 3x squared is equals to 2 sine of u, but sine has a square on it. When you take a square root on both sides, this becomes root 3 x. X is outside the root, remember. And on the right-hand side, we shall have root 2, but square root of sine squared is sine of u. So that is what we shall have at that level. Then what do? You can make x the subject if it is a choice. X definitely becomes root of 2 out of root of 3, root of 2 out of root of 3, sine of u. And therefore, dx du can now become, by the way, when you have a root on 2 and a root on 3, it's as good as writing a square root of 2 out of 3, square root out of 2 out of 3. Then remember, we are differentiating this. You differentiate sine of u with respect to u, you will get cos of u. So make dx the subject. Dx now becomes root of 2 out of 3. Let me elongate this root sign. So it's supposed to be root of 2 out of 3. Then cos u, then du. There we are. Now, after this, we shall go back and do the substitutions. I say now integral of 1 out of 2 minus 3x squared under the square root sine dx is going to be the same as integral of 1 out of, remember, we are now going to be substituting 2 minus 3x squared for, 2 minus 2 sine squared u for 2 minus 3x squared. So this will be 2 minus 2 sine squared of u. And dx is root. Now this time around, I can break it down again, no problem. Root of 2 out of root of 3. Cos of u du. Cos of u du. Then from this point, remember, 2 is a common factor. Pull it out. We shall have a root 2, which will cancel with a root 2. Okay. You remain with 1 minus sine squared. which is cos squared, but square root of cos squared is cos. So if you go slowly, you will get to a level where things get so simplified. So I can say 1 out of, first of all, I can identify root 2 here. Because when I pull out the 2, it will be 2 but within the square root. Then I also have a square root of 1 minus sine squared, which is cos squared of u. Cos squared of u. Then times root 2 out of root 3 cos of u du. Then from this point, root of 2 and root of 2 will cancel. I can decide to pull out 1 over root 3. Then I remain with cos squared of u and the square root, which is the same as cos of u, but cancelling with the other cos of u. So it means I'll now have integral of 1 with respect to u. And at the end of the day, we can say the answer will be 1 over root 3. It would be u. It would be u, yes, 1 over root 3u. But remember, on our left-hand side, we have integral of 1 out of 2 minus 3x squared with respect to x. So this will be 1 over root 3. I get back here. I say this would be u, yes, but I want u in terms of x. I want u in terms of x. Get back here. I say from this very step here, if I was to make u the subject, I would first divide by root 2, both sides. Then I take the sine inverse or the arc sine. So it means I can see that u will be sine inverse. It would be sine inverse of root 3x but divided by root 2. Divided by root 2. So that is our final answer for that integral. Quite easy as long as you follow up the steps very well. So let's move right away. Example number 3. Okay, there we are. That is our example number 3. Says find the integral of 1 out of square root of 3 minus 4x squared with respect to x. What do we do in this case? Quickly, without wasting a lot of time, I will say let 3 minus 4x squared, the whole of it, be the same as 3 minus 3 sine squared of u. The trick is maintain this constant as you see it here. So now from there, by comparison, definitely I'm going to go direct. We can see that we get 4x squared is equals to 3 sine squared of u. When you take a square root on both sides, this becomes 2x, this becomes root 3, this becomes sine of u. And then you can differentiate, or you can first make x the subject. If you want to make x the subject, it becomes root 3 out of 2 sine of u. And therefore, from this level, you can get dx du. Dx du becomes root of 3 out of 2 cos of u. And then make dx the subject, dx becomes root of 3 out of 2 cos of u du. If you make dx the what? The subject. Get back here. Get back here and you say now integral of 1 out of square root of 3 minus 4x squared with respect to x. Remember, we already called 3 minus 4x squared to be 3 minus 3 sine squared u. So I will say integral of 1 out of square root of 3 minus 3 sine squared of u with respect to x. But remember, now the dx changes to become root 3. So we shall have root 3 out of 2 cos of u du, meaning we have changed the variables and therefore the respective integration changes from x to u. That is why we have dx here and then we have du there. Now from this level, we can all see 3 and 3 is common. When you pull it out, it's not a square number, so it will keep within the square root. So I will have this step as 1, integral of 1 out of, it will be integral of 1 out of root 3. Root 3 will be out. Then you also still have a root. You also have a root of 1 minus sine squared, which is cos squared of u. Now I have my root 3, by the way, up here. I have my root 3. I have my 2. I have my cos of u. And I have my du. So from there, root 3 and root 3 can cancel. Root 3 can cancel with root 3. We shall now have a half outside the integral sign. And once you have a half, cos u will cancel with cos u that we obtained from square root of cos squared of u. So that we have a half integral of 1 du. And that means if you integrate this, it will be a half u plus a constant. But remember, for us to write our answer in terms of x, we shall now conclude by saying integral of 1 out of square root. 1 out of square root of 3 minus 4x squared with respect to x now becomes a half. It's supposed to be a half u, but remember u can be made the subject from this level here. This level, when you make u the subject, becomes sine inverse. To become sine inverse of 2x out of root 3, and then we say plus a constant of what? Integration. That would be our conclusion for that, and that is indeed the integral of 1 out of 3 minus 4x what? Minus 4x squared. It is as simple as this. I really believe with these 3 examples, I can now give a few questions for our serious learners out there to try out. And in case of any challenge, give us feedback. Okay, so this is our simple exercise that we shall try out. Just given a few questions, they are 5 in number. You will try them out, and after trying them out, in case of any challenge, we're always there to help you. Remember to subscribe to this channel so that in case any new video is uploaded, you're always updated. And please remember, I also offer one-on-one tutoring services. I have a team, a strong team that does all the sciences. We do all the syllabi from all countries. So in case you need such services, you can as well contact me and you get that best service. Thank you so much, and I wish you well for today. Bye-bye.